In this video, we're going to look at the examples in section 2.4. We're going to start with this problem, which is basically the first 4 pages of the slide set and comes down to these questions here. So we're asked here to determine how many of the applicants for this position are skilled in only copywriting. Okay, well, for that, we just look here to this region in C that doesn't intersect G or L, and that we can see that there are 5 people in that set. How many applicants have exactly 2 of the 3 skills? For that, we look at these regions, which overlap 2 of the skills, but don't include all 3. That's 7 plus 4 plus 3 is 14. Finally, we're asked how many applicants are in the pool, and for that, we're just going to add up every number in the whole thing. 5 plus 7 is 12, plus 5 is 17, plus 4 is 21, plus 2 is 23, plus 3 is 26, plus 6 is 32, plus 4 is 36 applicants in the pool. Next, we are asked to determine if, well, we've got a couple of problems here. The first asks us to determine the number of agents, the number of items in A, given some information about A and B, and then we have to determine the number of agents in a group. So we'll start with that first one. There we go. Okay, find n of A if the number of elements in the union of A and B is 22, the number of elements in the union of B and the intersection is 8, and the number of elements in B is 12. So if we take the number of elements in B away from the number of elements in the union, we get 10, and that is going to be the number of elements in A that are not in B. Or the number of elements in A and the complement of B. Now, this is the number of elements that are not in B and in A. This is the number of elements that are in both B and A. So the number of elements in A is equal to the number of elements in A. We'll do it this way. A union B minus B plus the number of elements in the intersection, which is 10 plus 8 is 18. This next one is more complicated. We're given a bunch of information about a group of agents investigating illegal activities on social networking sites. We've got agents on Twitter, agents on Facebook, and agents on LinkedIn, and we want to know how many agents there are total, which is not the easiest question to answer. So what we'll do is we'll make a Venn diagram and we'll figure it out. So this is Twitter, this is Facebook, and this is LinkedIn. Okay, we're told we're going to start from the very last bits of information we're given here. The number of elements in T intersect F intersect L. So the number that are on all 3 sites is 5. And the number that aren't in any of the sites is 3. Next, we go to this column here, where we're told the number that are in Twitter and Facebook is 9. Well, we know that there are 5 in all three, so we take the 5 away from that 9 to get 4. Likewise, the number in Facebook and LinkedIn is 10, but there are 5 in all three. So there are 5 who are on only Facebook and LinkedIn, and the number in Twitter and LinkedIn is 6. There are 5 who are in all three, so there's 1 who is only in Twitter and LinkedIn. Now we come over here to this last column, or the first column really, and we see there are 13 total agents on Twitter. Okay, well, we've accounted for 10 of them here in these 3 areas. So there are only 3 remaining who are only working Twitter. We have 14 who are working Facebook and something else. So there are only 2 who are working only Facebook. And there are 11 working LinkedIn as well as others. So there are 13 total. 13 minus 11 is 2. Okay, so now we've determined how many agents there are in each group, and we just add up these numbers to figure out how many total agents there are. 3 plus 4 plus 2 is 9. 5 plus 5 plus 1 is 11. So that's 9 plus 11 is 20, plus 2 is 22, plus 3 is 25 agents total. On the last page here, we are given a table, which I've duplicated on my page, and we want to find the number of people in each set. So we're looking at Y intersect C. That's the number of young people who drink cola. That's right there, 45. Then we're asked for the number of people who aren't older, they're over 33, they're not exactly old, intersected with the number of people who drink iced tea. So we're going to take the number of this set, and that's going to be equal to all of these people plus the number of older people who drink iced tea. Okay, so that's going to be 90, that's the younger people, plus 75, the middle people, plus 30, the number of older people who drink iced tea. Okay, so that's 120 plus 75 is 195. That is it for this video. If you have any questions, please get in touch.